Hey, welcome back to AI Tech Hub. I'm Techie. You know, if you're building machine learning models, you're absolutely going to run into this massive, incredibly frustrating problem that literally every single ML team hits: sheer chaos. Data scientists naturally move fast, right? You're tweaking code late at night, trying out completely new algorithms, adjusting data sets on the fly just to see what sticks. And then suddenly, you've trained 50 different versions of a model, and you genuinely cannot remember which precise setup produced that one amazing result. Well, today we're diving into MLflow. It's a tool that exists specifically to solve this exact tracking nightmare. By the end of this explainer, you're going to understand exactly how it can completely transform your machine learning workflow. All right, let's quickly map out our itinerary for today's lab tour. We're going to cover 1, the machine learning chaos; 2, the digital lab notebook; 3, the specimen vault; 4, MLOps and portability; and finally, real-world action. So, Section 1, the machine learning chaos. Let's get right into it. Let's dive right into the core of this problem. It is a massive roadblock every single machine learning team eventually slams into headfirst. And usually it happens right when you're under a super tight production deadline. Because training a machine learning model, it isn't a one-shot, simple process. It's dozens, sometimes hundreds, of iterative experiments. You're tweaking a learning rate over here. You're trying a different set of features over there. Or maybe you're feeding it a massively different amount of training data. Each attempt produces a model with slightly different performance characteristics. And then, the painful question inevitably pops up. Which specific combination of settings actually produced that one really good result you saw 3 days ago? Did you change the training data since then? Actually, is the model file you're looking at on your desktop right now even the one that performed the best? This completely illustrates the divide between two very different ways of working. Without a real tracking system, you are relying solely on memory and maybe a few scattered text files? It turns into chaos incredibly fast. Teams end up wasting enormous amounts of time just rerunning complex experiments they've already done. Or consider the absolute nightmare scenario. You deploy an unverified model file to production, user complaints immediately start rolling in about bad predictions, and your whole team is frantically trying to reverse engineer which file actually made it to the server. But when you have meticulous tracking, your work becomes totally reproducible and traceable. That means confident deployments every single time, without the panic. Moving right along to Section 2, the digital lab notebook. Okay, I want you to think about a meticulous scientist running a long series of complex chemical experiments in a physical lab. They don't just rely on their memory, right? No way. They keep a highly detailed lab notebook. Well, MLflow is essentially that exact same lab notebook, but built specifically for machine learning experiments. This first core piece of the tool is called experiment tracking. Every single time you run a training job, MLflow logs it automatically as a run. It captures the specific settings you used, which in ML terms we call parameters. Think of parameters as your dials, like your learning rate or the depth of a neural network. It also captures the resulting performance numbers, which we call metrics. Think of metrics as your grades, like your overall accuracy or error rate. And the best part? It does all this automatically in the background. You never have to manually write any of it down yourself. This digital notebook is just incredibly comprehensive. Because you're logging specific parameters, the exact versions of your code and data and your performance metrics all in one single place, you're building up this complete, highly searchable history of every experiment you've ever run. You can pull up a dashboard, confidently compare experiments side by side to spot overarching patterns and what's actually working, and never, ever lose track of a successful formula again. It seriously gives you complete visibility into the entire evolution of your AI project. Which brings us to Section 3, the high-tech specimen vault. So what happens once you actually find a model worth keeping in that digital notebook? You definitely need a highly secure, reliable place to put it. Think of the model registry as a high-tech specimen vault sitting right next to your digital lab notebook. It's this secure, highly organized central system where your successful formulas actually get stored, labeled, and formally versioned. It is always ready for you, or literally anyone else on your software team, to easily check out those verified formulas. This means pulling the model seamlessly into an application without ever having to wonder if it's the finalized artifact or just some messy draft you forgot to delete. The registry lets you formally track versions over time and clearly mark their exact status, which is absolutely vital for any collaborative environment. For example, version 1.2 might be strictly labeled as experimental for testing out new features, while version 1.5 is explicitly approved for running in production. This matters enormously in real, fast-moving teams. When a software engineer pings you and asks, hey, which specific model is actually running in our live app right now? There is absolutely no ambiguity. The Vault clearly labels the approved champion model. All right, let's look at Section 4, MLOps and model portability. Let's step out of the Vault for a second and see how these models actually connect to the broader software ecosystem. Because, let's be honest, a model isn't very useful if it's permanently trapped on your local machine. MLflow standardizes how a trained model gets packaged. It essentially wraps the model in a standardized format that allows it to reliably run in different places, whether it's your local laptop, a teammate's machine halfway across the globe, or a massive production server in the cloud. Standardized packaging ensures you don't run into those super frustrating compatibility headaches when it's time to hand the work off. Now, if you watched our previous Docker explainer, this concept should sound very familiar. It's the exact same core philosophy, creating a standardized software package that runs identically no matter where it's deployed. But MLflow solves this problem specifically for the trained machine learning model itself. It ensures the model can be reliably loaded and used, completely regardless of the specific software environment or the hardware it was originally trained on. And this all connects beautifully to a broader, highly critical discipline called MLOps. Just think about how manual file shuffling works when you don't have this system, passing raw model files via Slack, completely forgetting to include a text file of required dependencies, and causing production servers to absolutely crash when they try to run your code. It's incredibly dangerous. Do you remember how our CI/CD explainer focused heavily on automating the testing and deployment of regular software reliably? Well, MLOps applies that exact same automated trust to machine learning. Instead of just crossing your fingers and hoping for the best, MLflow provides the rigorous tracking and registry infrastructure that completely powers automated, trustworthy deployment pipelines for your AI systems. Okay, let's tie this all together in Section 5, Real-World MLflow in Action. Let's make this totally concrete and look at how the notebook and the Vault work together in a real-world scenario. Imagine a data science team is building a really complex model to predict customer churn. Over a few weeks, they run, say, 80 different training experiments, adjusting features and complex mathematical settings each and every time. Now, 80 experiments isn't just a number. That represents massive volumes of data, countless minute changes, and thousands of discrete data points. Trying to do this manually, it would be basically impossible. But instead, MLflow's digital notebook automatically logs every single one of those 80 runs. When the team finally spots a version that clearly outperforms all the rest, they don't just awkwardly save it to a desktop. They register it directly to the MLflow Vault, formally marking it as the approved version ready for production deployment. Then, let's say 3 months later, a brand new teammate joins the project and asks this totally inevitable question. So, which specific model are we using and why? Without MLflow, the answer is usually scattered across buried Slack messages and long-forgotten sticky notes. But with MLflow, the answer is perfectly documented. The precise parameters used to train it, the specific performance numbers it achieved, and the official approved version are all sitting right there in the registry, reliably tracked from day one. And finally, Section 6, Explainer Recap. We've covered a ton of vital ground today on our lab tour, so let's carefully review the core components of what we've just learned. MLflow isn't magic, guys. It is simply a highly disciplined tool that replaces total chaos with order. The digital notebook tracks your specific settings and results automatically. The Specimen Vault securely stores and versions your approved models. Standardized packaging ensures those models are perfectly portable across literally any environment. And together, these features form the solid foundation for the tracking side of MLOps, bringing robust CI/CD style reliability straight into your machine learning lifecycle. Now, I want to turn it over to you. What part of the machine learning lifecycle is the absolute hardest for you to keep track of right now? Drop your answers in the comments below so I can make sure to cover your specific roadblocks in our future explainers. Thanks so much for joining me here at AI Tech Hub. Keep experimenting, and I'll see you in the next one.